In this demonstration, I'll show you how to find the derivatives of inverse trigonometric functions. This is part 2 of the series. This represents a table of derivatives in inverse trigonometric functions. Oftentimes, your professor will not expect you to memorize these, but you should be able to use them and also be able to prove them as shown in part 1. Let's start off with question number 1. In question number 1, they are asking us to find the derivative of cosecant, the inverse, 5x squared plus 1. So we'll use our table here, and our table tells us that the derivative of cosecant inverse is equal to this. So whatever this value is, now in this particular case that value is x, you replace it everywhere you see an x. So in our case, this is our x. So you would use this as a template and replace all of these x's with this. Now, in addition to that, when it comes to finding the derivatives of trigonometric functions, you also need to take the derivative of this and multiply it to the derivative of that. Let me demonstrate what I mean. Let's write out this part, but instead of the x's, we use this. 1, and I'm going to put the minus here because that minus originally was over here. I'm just going to put it at the top. 5x squared plus 1. I'm going to put it in parentheses. And the square root of that, which gives us 5x squared plus 1. And remember, this is squared. So square that minus 1. In addition, just like with all trigonometric functions, you do need to find the derivative of this and multiply it to the end. Finding the derivative of this is quite simple. Here we'll use the power rule. 5 times 2x, and you reduce this by 1, gives you 10x, and this 1 goes to 0, so you can just leave it like that. There you have it. That's how to find the derivative of question number 1. Let's proceed to question number 2. Here we're introduced to some new terminology. Arc cosine is the same thing as saying the inverse of cosine. So just keep that in mind. And also, this expression contains two terms. So we have this term and we have this term. So it's a product essentially of two separate terms. And as such, you will need to use the product rule. The product rule tells us that if we call this f and if we call this g, you find the derivative of f and you multiply it to g, then you multiply the derivative of g to f. So let's follow that. Let's start off by finding the derivative of x. We'll do this, and the derivative of x is equal to 1. And we're going to leave arccos the way it is, and feel free to use cosine inverse of the square root of x plus, now this time we need to find the derivative of arc cosine. And we're going to go up and use this right here. So let's try to memorize that quickly. 1 minus the square root of 1 minus x squared. All right. So let's bring that down here. And remember, you will need to mix and match the x's with the following. So let's do that. Let's write this out the way it is. Negative 1, 1 minus, and watch this. This is the radical. It is the square root of x. And this is a square of x. So if you think about it, if you square a square root, you end up with simply the base. So here, you would have x. Okay, just keep that in mind. Don't forget. And also, you will next need to find the derivative of this part and multiply it to what you have going on here. What is the derivative of the square root of x? Well, that's not hard to do. I'm just going to shift everything over so that you don't get confused. Now, we need to find the derivative of this. And here it is. So the square root of x is the same thing as saying x to the power of 1 over 2. And this 1 over 2 goes to the bottom. We're using the power rule here. And this gets subtracted by 1. So you end up with negative 1 over 2. And another way of writing this is 1 over 2 the square root of x. Now, of course, some teachers might not be happy the fact that you have a radical at the bottom, but for the sake of this video, we'll just keep it as that because it looks neater. 1 over 2 the square root of x. And of course, we are finished finding the derivative of arccos. Next, you'll have to place f beside it. And there you have it. This right here represents the derivative of question 2. If you found this tutorial helpful, please support our channel by subscribing or by liking this video. If you have any further questions, you may visit our website at biology-forums.com. We are an online service for students seeking free homework help. See you soon.